Hi there and welcome to Wade's Workshop. This will be shed talk number 2, I believe. So yeah, just a general chit chat. I'll let you know there's a few things I'm going to be doing today. I've been up to my neck in work, production work, sort of trying to earn a living, so to speak, filming for people, doing odds, bits and bobs. I've got an order for like 70 odd of those aluminium rings you've seen me do in the past, the turning on a mandrel ones, those. You saw me make some brass little extender bolts this week. I've got all sorts of bits and pieces on, which takes me away from the workshop, so I've been a bit slower getting videos out. I think it's been about 5 days since my last one. Anybody might be able to give me a little help with this one, just a bit of feedback. I got this 4-inch vise here, and I need some soft jaws for it. Now my first thought was, yeah, bit of sheet aluminium, folded, beat them to shape, clip on so they just drop in the vise. But I'm always holding aluminium in the vise, so I'm thinking sort of nylon, something like that. Don't want to buy material for the job, you know. Recycling is always the way forward, you know, whatever you got lying about. Wood, no, not really, but I think nylon would be the way forward. So if anybody can think of anything like I don't know, like a ready meal container that's made of some sort of strong plastic that I could sort of form over, you know, something along those lines. I mean, I've got various plastic containers. I've got this one with the brass nuts in. That sort of thing could be cut in half and would fit on there. But somebody might have done it before. I don't know. Anyway, if anyone's got any ideas, feel free to comment below on what I could use to make the, you know, sort of household throwaway stuff that's likely to be lying about in most houses that I could use for that purpose. So that's a question for everybody. Let's see what sort of replies we get on that. I have made, and I'll show you the footage of that, the startings of a winding handle. No real design to it. You've seen me do it before. I make it up as I go along. So I made it up as I go along, made the aluminium plug, recycled an old roll bolt, like a ground anchor bolt, that sort of thing for concrete, a couple of 10mm nuts and a washer. I've tried it out. I'll show you the footage of me making this and trying it out, and yeah, very pleased. Nothing too elaborate, no quick release ball detent handles. I was thinking all along those lines of what to do. In the end, it's probably the most practical way for me to use the winding handle for the chuck is going to be with the 17mm spanner. So that's that. I've had a few parcels arrive. I'll show you the footage of that. Ordered a few nice bits and bobs. As you saw in a previous video, I needed a 6mm collet, and I keep buying collets in odd sizes as I need them. But what I've been doing is getting 3 Morse taper collets, because the spindle of the lathe is a 3 Morse taper, and you know, this particular one is an 8mm, so anything 8mm stock, you know, pretty much nominal 8mm stock will fit. I mean, it'll probably take 5/16 as well, but yeah, 8mm stock. I use a draw bolt through the back of the lathe, pulls it in, and I can hold stuff straight into the 3 spindle of the lathe. Now, I'll throw that box on the floor, but yeah, I think I've got an 8, a 10 and a 12, which are the odd milling cutters I've got. And I work pretty much all the time in metric, so the metric ones work well for me. So I won't bother picking up that box just yet. I should do it straight after this shot. Right, that's pretty much it for this episode. So I've got the making of the handle and the arrival of a few new bits and bobs, and you'll see what they are as we go along. Those of you that saw me making the tailstock die holder, if you haven't already seen it, there's 3 episodes of making a tailstock die holder, would have seen that I was having trouble with low torque at low speeds with the lathe, and I pretty much worked out that I'm going to need to put a winding handle on the back of the lathe. Now, the low torque doesn't cause a problem that often, only when you're turning very slowly, trying to put a thread down something with a die holder, that sort of thing. Generally speaking, it doesn't cause me any problems at all. If I'm parting off something in a large diameter, I could have problems, but you just take it easy and what have you. Several ways I could overcome the problem. I could change it to an inverter motor. I could change the pulley diameters on the back so that the motor is running at a higher voltage for the low speed I'm looking for. Lots of ways I could do it, but it doesn't cause a problem often enough for me to go that deeply into it. And for the odd occasions when I do need to, you know, have I got multiple parts that need threading, rather than put a spanner on the chuck, a winding handle on the back of the headstock was my conclusion, the simplest way that I can go about it for the rare occasions that it causes a problem. So I was rooting through a few old boxes of bits and bobs. We've all got like a nuts and bolts drawer, that sort of thing, of stuff that's left over from various products or projects. And I came across this, which is the inside out of a concrete anchor bolt. Now it's an M10 thread. It's about, let's have a look. Should have had a look beforehand. It's about 90 millimeters long, and it has a taper on the bottom which would have expanded the original anchor bolt. I thought, well, that's a good basis for the expanding bolt for an expanding collar that's going to fit up the tunnel at the back of the lathe, in the back of the headstock. I don't know how accurately this has been machined, you know, how accurate the taper is to the thread. So I think the first thing I'm going to do is just sort out this taper on the bottom end to make sure that it's running true to the thread. And that's a quick little job in the lathe, so I'll show you that. So I'll just hold it gently, 3-jaw chuck on the threads, not breaking its neck. I don't want to flatten those threads off too much. And what I've done is set my compound slide off camera to the approximate angle, or very near to the existing angle on the end of the bolt. So as you can see, it is wobbling about a bit. Let's bring you in a little bit closer on this. Yeah, there is a bit of wobble on that. So what I'm going to do is, using the compound slide, I'm just going to come back somewhere around here, just about touching there. Just set the zeros on my DRO. I'm going to wind back the compound slide. Yeah, not quite touching there. Let's just see how my angle runs. Just touching on the top. So I am a little bit out. But not to worry. Now I've locked the compound slide here. So when I come to do a matching taper in the bore of my expanding collar, I'll use the compound slide without moving it from its setting now to machine the same taper. And I'll probably have to machine it on the back side of the hole with the lathe running in reverse, so that's something a little bit different. Just take a little scratch in there. Now it's an M10 thread, and that plain diameter behind this tapered head is actually only about 9mm. It's well under the thread diameter. So the only bit that will be acting on the expanding collar will be this taper. And having done this, I now know, or know now, that this taper on the end will be running pretty much concentric with the thread. Let's take a quick look at that. See if I've cleaned up all the way around. Not quite. Another couple of scratches on there. So I'm going to machine a taper that matches this on the inside of my expanding collar, shall I say, that's going to lock in the tunnel towards the back of the headstock. I'll just take one more little scratch off there, 0.1, something like that. Actually seems to be quite tough material, this. It's probably a high tensile material of some description used for an anchor bolt. I don't particularly need anything that strong, but it was something I had lying about. And there we are. That's cleaned up that taper concentric to the threads. So the idea is that you drop the bolt. No, the idea is aluminium slug which fits neatly down into the bore to a shoulder, perhaps a smaller shoulder that'll fit through this hole to come out perhaps sort of 7 or 8mm, and then it can go to a larger diameter. So this will be inside the aluminium from the back, and then we'll have a nut on this side so that when you tighten the nut, it pulls this back into the aluminium, and because it'll be a split collar, will expand the aluminium and lock into the tube of the lathe. I will then have probably a bit of a working out sketch, enough left so that I can probably wind a handle onto what's left of the thread, so that when I rotate in this direction to thread on the end of something, you know, on the end of a, you know, whether it's an M6, M8, what have you, that the handle is always tightening. I can then take the handle off the other way. I could put a lock nut on the other side of the handle so that I can wind in both directions, wind a thread on and wind a thread off, that sort of thing. But that's the general idea. So we'll make up a little sketch of the lengths and diameters. The first thing we need to know is the diameter of this bore. Now I've got a little telescopic gauge here. And it's not very accurate, this bore. I can see it's machined and feels quite rough. I haven't given it a wipe out. So I'm going to be approximate with this. And I think I've done this a few times before. It measures up around 22.17 to 22.2, something like that. So I'm going to do it 21.2. So I'm going to machine the part that fits in here to 21.1 diameter. So I want 57 mil. So let's just mark a line on our aluminium. Around about the 60 mil mark, that'll do me. Not very clear. Just mark it with a Sharpie roughly in that area, so I know where to chop it off. I could part this off, but as you're about to see, there's a far easier way to do it. So I think we'll use a 12-inch rule for this one. So basically what I'll do is use the old rule chop trick. Line it up carefully on the line, chop it off. So I could put it straight up in a 3-jaw chuck like that, but as you can see, the jaws are sticking out a long way. So far, in fact, that if I just turn just a little bit, that jaw, in fact that jaw is loose, not even engaged. Still not engaged, and I'm there. I'm only a quarter turn away from grip. So I'm only engaging the scroll on one tooth of that jaw. Not happy with that, so I'll put the reverse jaws in. So as you can see, I've got the reverse jaws in now. With the chuck completely closed, it won't go on the outer step. So I'll have to open it up. And there we are. It'll have to go on the inner step. I'll face this off, put a centre in, rough it out. Started it up and it is wobbling a bit on the end, so I'll just get my push tool on it. That's better, now it's running true. Tighten up on the chuck. I don't know why I check all 3 jaws. It's not strictly necessary, all 3 sockets on the chuck, to tighten all 3, because it's a self-centering and will centre off one, but it's just a habit I've got into when I want something tight, especially when it's only gripping on like 6mm in the back, just to make sure. So as per normal, it is sticking out a long way, so I'll just gently face this off. It's actually only sticking out about 50mm, but I'm only holding on the sort of 5mm step in the jaws. And I'm going so slowly there, hang on a minute, that's better. More like it. Let's take a clean up scratch. That's it faced off. We've got a WD-40 on there. What I tend to do, I've got this bristle brush, it's a bit grubby actually. If I squirt a few squirts of WD-40, it seems to hold it quite well in the brush. Right? Anytime I'm using aluminium, I can just dab it onto whatever I'm machining. I need to go a little faster for the centre drill. What are they running at? 1100 RPM, something like that. Always need to respect centre drills. I tend to, when you look at the depth of the centre drill, especially if you're going to use it for centering rather than for drilling, is to wind it into a point where you're about sort of 2/3 up to the taper. And that should be more than adequate to hold that small part. So, according to my drawing, I want to come 35mm back to 21.1 diameter. So I just set a 0 on that front face. Bring the DRO where you can't get it in shot, I'm afraid. I set a 0 on the front face with a tool. Let's come back. I'm going to go 35 down to 21.1. So, taking a 1.5 mm side, and I keep going to my DRO reads, I don't know, 34.8, something like that, just cut 0.2 off the back end, and that's about 2.5 mm a side now, taking 5 mm off the diameter in one cut. Aluminium's building up like an absolute what's it, but at least it's not spraying hot aluminium on me. Normally the point where aluminium sprays into your face. 34.8. I'll bring you back when we're somewhere near. The finishing cut, the WD-40 off my brush. I'm using these specialist tips for aluminium, they're carbide tips for aluminium. So it's a 0.2 finishing cut, just run that across under feed. For anyone that machines a lot of aluminium, I really would recommend getting these tips. I'll dig out the packet and let you know what they are, the particular ones I'm using. There's a 1 letter change in its normal tips from the normal general purpose. There is a change of 1 letter in the sort of designation of what it is. Right, so come back in there, finish diameter, and I'll just base the back face, taking the final 0.2 to a distance of 35mm to the shoulder. Just come into that corner. That's it. So that's my first step. So these tips that I'm using, these specialist ones for aluminium, they're TCGT 110204. That's the designation of them. And I believe it's the G which says that their design is for aluminium. But the particular ones I'm using, they're the triangular ones, TCGT 110204. So I now want a 7mm wide shoulder. And I want it at 26 diameter. I'm just going to put a 45-degree chamfer on the end. Nice big one here. Not quite. That'll do me. Excuse me. You'll notice that I'm using a triangular tip to put 45-degree chamfer on. And as you'd imagine, naturally a triangular tip, that won't give you 45 degrees. So I've ordered, again, another 12mm lathe tool that takes square tips with a 45-degree approach angle so that I can have my tool post square, and that will give me the ability to come in to somewhere like this, where if I skew my tool post round, it's going to hit the chuck. And that's something I can have basically set up permanently as a chamfering tool. So this one is going to have a little chamfer, but I'm afraid it's going to have to be at 30 degrees, not 45. So I'll get on and drill it. So I'll put a 6mm drill through first, all the way through. I'm sure you don't want to watch me drilling a hole, so I'll bring you back when I've done that, and then we're going to follow it up with a 9.9 and then check the bolt in the hole. So that's it, drilled out 12mm diameter now, 5mm deep. So the next job is to put the taper in there to accept the head of the spreader bolt, should we call it. So knowing that I was going to need a very small boring bar, the smallest one I got, tip one is 10mm. But I got a piece of 5/16 Momax, high-speed steel, and it's ground up into a boring bar. And I'm sure I'll be able to pick up from that 12mm and using the compound slide, bore a taper in that hole. So that's the next step. So this shot is a little bit unorthodox. It's from directly overhead. So I'm just winding a cut on, or a feed on, and machining that taper, because the compound slide is still set to the same angle as it was when I did the bolt. I've just set that boring bar up while it's here, put the lathe in reverse, and I'll just put a little 45-degree chamfer on the end of that 12mm board. And as you can see, I was chamfering on the back face, so the lathe was running in reverse. So I got a 45-degree chamfer, 12mm deep, 5mm deep at 12mm, and then tapering at a matching taper to this into my 9.9 drill bore. So it does fit the 9.9. I haven't tried that. I don't want to put it right in at this point because I won't be able to get it back out again. But having said that, next step's going to be take it out of the chuck anyway. So yeah, that now fits down inside there quite happily. So I flicked it back around the other way. It does run really quite well, this 3-jaw chuck. Certainly less than a thou of accuracy, I would have said, depending on what diameter you're holding on. But I've changed the jaws on with the external jaws, flick the job around. I'm just going to face this face, take a skim off the OD. I can always play with that afterwards. Again, I'm not going to reduce it down that much on the grounds that you can always take more off, you can't put it back on again. Right, so that's that faced. And we'll take a skim off the OD. Just touch off. Here we go. Maybe, I don't know, 0.5 off the diameter. Quick skim. 1000 RPM. Swarf is a bit stringy. Almost cleaned up there, just a tiny bit. Another 0.1. We'll have a chamfer on both faces. In fact, that does look way too big. I'll take a couple of mil off that, I think. I know, keep your hands out of it. Aluminium's not too bad actually, but I wouldn't do it if it was on the job. Just take a finishing cut across there. I'm going to chamfer both sides. So where am I at? Or being Welsh, I should probably say, where am I to? But where am I at? I didn't allow for the bolt and this cover here on my distance for the smaller shoulder. I allowed 7mm to miss this back cover, but as it turned out, I needed 10mm. So I machined out to 10mm step. And there's my aluminium slug which is going to go in the tube. So the 10mm bolt fits down into the taper, and it fits the collar of the lathe, and it misses the screw. So my next step is going to be to cut. I'm not too worried about concentricity, so I'm just going to cut 2 hacksaw cuts at 90 degrees to each other, so there'll be 4 slits in the end of here, down to, let me see, I know that's 5mm down. I know it's 5mm down, so another 10mm for that, 15. Probably going to go about 18mm down from the top face. So I'll mark a line 18mm and I'll hacksaw 4 grooves. Just using a riffler file, little B-pointed riffler file. If there's one thing I have got lots of, it's needle files and riffler files from my days of mould making many lifetimes ago. And just deburring and putting a chamfer on the inside of those junior hacksaw grooves. Difficult for me to show you this on camera. There we go. Just do the outside with a normal sort of 3-corner needle file now. So I fitted the 10mm nut and washer on the back. And my first snag I've come up across is I can hold the chuck and stop the spindle revolving, but I've got no means by which to stop the whole thing revolving while I'm trying to tighten it up. So what I need is another pair of M10 nuts on the end, and I can actually fasten my winding handle, which is going to be a spanner, which I can pull on and off. I mean, that is the best quick release handle, is a spanner that I can put on the end and hold the 2 locked nuts to tighten up to fasten the whole lot in the what's it. Now I've searched high and low, and they said they haven't got any 10mm nuts, so I've been to the shop and got some more 10mm nuts. So another 2 10mm nuts, and I'll just lock those together on the end of the shaft. That's those locked, and that will enable me to hold the spindle, tighten up on that nut there, which will draw back the bolt into the taper, and now that is solid to the headstock. Oops. So what I'll do is whack the e-stop, because I don't want to turn it on in gently, and I'll get a bit of 6mm bar and I'll try tapping with it, or running a die down a bit of bar with it. So let's give this a try. I got an M6 die in, a bit of 6mm, hang on, take the lid off the bottle, a bit of 6mm diameter silver steel, or I think it was 15 or 12 diameter silver steel, turned down to 6mm diameter over about 20mm. My tailstock die holder is there. 17mm spanner on the back here. Pull it forward, get started. There we go. It did have a few threads on the end, this piece. And as you can see, that is working. Just break this, what's it? Absolutely wonderful. There's the shoulder. Wind it back off. I could have put the lathe in reverse to do this. Take the handle off, put the lathe in reverse and wind it back off. And that is it. M6 on the end. No problems at all. You know, I've been thinking about this. Dangerous when I start thinking, but some sort of handle that was spring loaded and always came off so you couldn't leave it on. But for when I'm using it, a spanner here, winding round, does the job. Now, I think I have got a 17mm spanner somewhere, another one, an old one, ring spanner. I could cut the end off, drill it, put a handle in it, so it gave me like a handle on a 17mm spanner. I could use a piece of aluminium and file a 17mm hexagon into it. But for the amount of work that I'm doing with it, you know, this is more than adequate. So when I want to remove the handle, the winding handle, first you need to get the right spanner, throw everything all over the floor, and then basically, if I hold the nut on the end, loosen off this nut, give it a little tap, and out it comes. It's as simple as that. And when I come to fit it, pull that back, tighten up the front nut, hold that one, tighten it up, and then that's locked again, ready for use. The only thing is, it is dangerous should you turn the lathe on and you've got a spanner on there. As you can imagine, the way those nuts have locked, the spanner won't go right on there, and it you know, it is quite reluctant to stay on there. But when you're winding, no problems at all. So I think as far as having a handle on here with a, you know, maybe a shoulder bolt and a nice handle for winding, I think that would be overkill for my purposes. A spanner just for winding threads in and out, absolutely no problem. And when I'm finished with it, loosen the nut, and you can see that bolt is still locked in there. Little tap on the end, and out it comes. Oh, throwing everything around all over the floor. There it is, finished job. The means by which to put a winding handle on the back, and it saves all the spanner on the jaw work, which is quite slow on the chuck end. So yeah, pleased with that. It's a simple, cheap, out of bits of scrap I found laying around. I mean, it was an old anchor bolt to start with, slug of aluminium, well, I've always got lots of that hanging around. And all in all, I probably 10 minutes turning, probably another 10 minutes putting the hacksaw groove in, and then another half an hour going up the shop because I didn't have any 10mm nuts. But yeah, there we are, little simple project. So a parcel has arrived with my new goodies. So let's open it up. Oh, like Christmas. A blunt pair of scissors I've got. I'm not allowed near sharp objects. Packed up like Fort Knox. My goodness. Right. Loads of junk, my invoice. Some bits of foam. That might be handy for something. So what have we got here then? Let me just lay it all out. Is that a clue? Right, get rid of all this rubbish. Let's start with these yellow boxes. I know what they are, and they're both the same. What we've got here are two, those scissors really are bad, blank Morse taper 2 arbors. Now they're hard on the shaft and they've got a soft end, and the plan is to make some center drill holders for the tailstock so that they don't have to use the chuck, so that I can pop the center drills in and they're spot on. So that's another little project, and I've got 2 of them, so I can have 2 different size centre drill holders. So the next thing I got is this orange box. Oh. And that's going to be my dedicated 45-degree chamfering tool that I referred to earlier on, and I have ordered some square tips with the specialist aluminium tips as well. Comes with a key, little end on it, nicely packaged actually. So that's that. So next we have a full set of ER32 collets from 3mm. They're all out of order in here for some reason, right up to 20mm anyway. So ER32 collets, all individually sealed in nice little box, which is handy. So collets are no good without something to hold them in. So we've got an MT3 to ER32 collet holder with nut and the appropriate spanner. That will fit directly into the headstock of my lathe. Not the ideal setup because a bar won't go right through and out the back. However, should in the future I ever get a milling machine, my plan is to get one with an MT3 spindle, and this collet chuck will not only be able to be used in the lathe but also in a possible future milling machine. So I now have an ER32 collet holder which will go in the lathe and possibly in the future in the milling machine. And that's not all. And then the final piece of the jigsaw, what will be ideal for the lathe, is a 100mm ER32 collet holder. Now this is designed to go on to a rotary table, something like that. It does come with 3 holes. They're not correct for my lathe. It's not that hard, the backing plate. So my plan is to turn in the back of it a register that will fit directly onto the headstock of my lathe. A counterbore with a register to fit exactly. I will then be in control of the alignment of the collet holder because I can make sure that everything's clocked up and it's perfect when I turn the register to fit. And then I can drill and tap 3 holes for the 3 studs to fit it onto the headstock of my lathe. So that's going to be the one that's used 99% of the time on the lathe. So you take off the chuck and fit that one. So there's a little project. You'll see me making that fit the lathe. Same spanner does both, and I have the collets, so it's pretty universal. The collets will come in for a future milling machine, but don't hold your breath on that one. But in the meantime, a bit of machining work, and I'll be able to get that to fit the lathe. So future machining work, machining this up to fit the lathe, and machining the 2 blank arbors that I've got for centre drills, and perhaps I can use the drill setup in this collet when it's done to drill the centre of these when they're in the tailstock. Who knows? Well, I do hope you've enjoyed this episode of Shed Talk. Just another note, I could have bought this ready-made from Banggood. They did have one that was ready-made, all recessed, correct studs, everything else to fit, you know, the smaller lathes. Having watched a few, seen a few reviews on YouTube of various people have said that they're worse than useless, and you know they weren't even accurate within like 8/10 thou, that sort of thing. So at least by buying the blank, it's given me the chance of getting the accuracy that I need by clocking it up, getting it exactly where I want it when I bore the register in the back to get everything lined up nicely. So that was why I went down that route. So anyway, as I say, I do hope you've enjoyed this one. It's been quite a long one. I've edited most of it already. It's just this final bit that I'm doing in my kitchen with the goodies that have arrived that I've got to add on. It's going to be another 3-4 minutes, I would have thought. Anyway, thanks for watching. And if you haven't done so already, please subscribe, guys. And don't forget, comments on the soft jaws for the vise. If anybody's got any ideas, you know, everybody has great ideas. And sometimes we've got to learn from each other. So, thanks for watching. Cheers, guys.